Greetings and welcome to the Introduction to Astronomy. In this week's episode of Multicultural Astronomy, we begin our look at Indian astronomy and begin with an introduction on that topic. So let's go ahead and get started. For as long as people have lived on the Indian subcontinent, they have watched the sky. The rising of certain stars signaled seasonal change. The phases of the moon marked ritual time. The motion of the sun structured agricultural life. Long before telescopes, the sky was already a calendar, a clock, and a guide. Indian astronomy did not begin as abstract theory. It began as careful observations, repeated, remembered, and recorded. In ancient India, astronomical knowledge was closely tied to ritual precision. Texts known as the Vedanga Jyotisha preserved some of the earliest systematic attempts to track celestial cycles. The goal was practical and sacred at the same time: to determine the solstices and equinoxes, to track lunar months, to reconcile solar and lunar calendars. The early tradition required accurate counting, careful sky watching, and increasingly sophisticated mathematical tools. Astronomy and mathematics grew together. Over centuries, Indian scholars developed a powerful mathematical astronomy tradition. They calculated planetary positions, they modeled eclipses, they refined numerical methods. By the early first millennium, astronomers such as Aryabhata and later scholars would use place value decimal notation, develop trigonometric functions, and improve planetary models. These were not isolated insights. They were part of a sustained intellectual culture, one that treated the sky as something that could be described precisely through numbers. Observation led to calculation. Calculation refined prediction. Prediction deepened observation. A continuous cycle of refinement. One of the most remarkable features of Indian astronomy is its continuity. For over a millennium, scholars built upon earlier work. Commentaries preserved foundational texts. New models corrected earlier approximations, and knowledge was transmitted through teaching lineages. Ideas traveled as well. Astronomical methods developed in India interacted with Persian, Islamic, and later European traditions through translation and exchange. Knowledge was not static. It moved, adapted, and accumulated. Indian astronomy is part of a broader human story. Across civilizations in China, the Islamic world, Mesoamerica, and Europe, astronomers were asking similar questions. How do we measure time? How do we predict celestial motion? How can mathematics describe the sky? In India, the answers took distinctive mathematical forms, but they were part of the same global conversation about the cosmos. This was not sudden discovery. It was patient refinement, generation after generation. In this series, we will explore individual astronomers, texts, and observatories. But before we study names, we recognize something deeper: a continuous tradition of watching, calculating, teaching, and preserving knowledge. Astronomy is never just about stars. It is about continuity, the passing of understanding from one century to the next. So that concludes this week's Multicultural Astronomy, introducing our series on Indian astronomy. We'll be back again next week to talk about our first astronomer of India. So until then, have a great day, everyone, and I will see you in class.